problem I will be doing problem 79. 79 says a spring of negligible mass and force constant K equals 400 newtons per meter is hung vertically, and a 0.2 kilogram pan is suspended from its lower end. A butcher drops a 2.2 kilogram steak onto the pan from a height of 0.4 meters. The steak makes a totally inelastic collision with the pan and sets the system into vertical system simple harmonic motion. What are A, the speed of the pan and the steak immediately after the collision? So for part A, first we just want to do conservation of energy, even though we know that there's no conservation of energy. So cancel out the masses, and we get and we plug in 9.8 for G, and the height is 0.4 meters, and the velocity we don't know. So we get 3.92 equals 1/2 v squared. Multiply this by 2, and we'll get and we get 7.84 equals v squared. So then we do the square root of 7.84. And we'll get the velocity equals 2.8. But since it's an inelastic collision, we have to multiply the velocity by the first mass, the mass before the steak was dropped on, by the second mass. So we'll do 2.8 times 2.2, the mass before the steak was dropped on, and 2.4, the mass after the steak was dropped on, and we get 2.6 meters per second for part A. Yeah, that's the answer for part A, 2.6 meters per second. And part B says what is the amplitude of the subsequent motion? So to find the amplitude, we want to use the velocity equation, which is v equals negative omega a sine of omega t plus theta. And we know there's a phase angle theta because he drops it vertically. So that means the phase angle is pi over 2, or 90 degrees, since he drops it vertically. And we know the velocity is 2.6, and we can find what omega is by, we know omega is root k over m, and we just plug in k, which is tells us is 400, and the mass of the steak with the pan, which is 2.4 kilograms. So I have root 400 over 2.4, which equals 12.9. So we plug that in, all this in, we'll have 2.6 equals negative 12.9 a sine of 12.9 t plus pi over 2. And so we know that it's right after the collision occurs. So we know the time is 0. So this just ends up being 0. And it'll just be sine of pi over 2. And sine of pi over 2 just equals 1. So we can take this out. So we'll just end up with 2.6 equals negative 12.9 times the amplitude. So then we divide by 12.9. excuse me. So then we end up with the amplitude equals 0.2 meters. And that is part A, or part B. And then part C says the motion of this period. So part C, you just use the period equation. Which is T equals 2 pi over omega. And we know what omega is, which is 12.9. So we just have to do 2 pi over 12.9 and we get and we get 0.49 seconds for the period of the motion. So yeah, those are the answers for 79.